Hey y'all, happy Wednesday. I wanted to take a minute to thank you for all of your hard work in learning how to do this online learning thing. I know that this is new for all of us. I'm obviously not a YouTuber and you guys are not used to learning online and your parents are not used to having to teach you at home, especially not materials that your teachers are creating for you. And so I just wanted to take a minute and recognize you and thank you because this is difficult, but you are doing it and I am really proud of you. I wanted to tell you about how this weekend I was cleaning my house. You know, I'm scared of the corona, so I'm gonna stay at home and I'm gonna clean my house and all that stuff. And I was thinking, you know, as I'm teaching online and I'm doing these videos, you're seeing little clips and bits and pieces of this workspace that I'm in. And I know that at the beginning of the school year, I spent all of this time creating my classroom and what I wanted my classroom to look like and the culture I wanted it to bring and how I wanted to arrange the seats. And I was thinking, how fun would it be if you guys saw the workspace that I'm working in now? So I'm going to take you on a tour of my apartment and show you what the place looks like. And in the comments below, I would love you to tell me where in your house you prefer to do your online learning. So let's go. So right now we're on my porch. Every morning I'll come out on my porch and I'll drink a cup of coffee, and this is where I'll answer any emails that came in the night before. This is my view out my backyard. I have that little lake that you saw with the turtle yesterday. And then we'll come into my apartment and we're in my living room. So this is my couch, and then you look over here and I have a bookshelf with my diploma, and then I painted that. And then we come over here. This is all my pre-algebra stuff, all my algebra stuff. I keep all of my shoes at the door. I'm super serious about not wearing shoes in the house. This is my pantry. Here we have my kitchen, my spice rack, my stove, microwave. I love my view as I'm standing at my sink and washing my dishes, and you can see into my bedroom there. As you can see, my kitchen is farm themed, and so I have chickens and I have a cow up here. These are all my friends that are getting married. Back here is my washer and dryer. And then you come over here, this is where I'll roll out my yoga mat and I'll work out over here. And then this is my desk space. This is what you have been seeing, where I'll do all of my math things. I'll sit at this table, or I'll teach from up here. In here we have my bathroom, all my skincare supplies, my makeup, all of that good stuff. I'm almost out of soap, I need to buy some. And then you come in here and this is my bedroom, and I make my bed every morning, and here it is. This is my space. We all know that real world math is a lot more complicated than textbook math or teacher made up math. So I'm going to show you an example that I made up, and then we're going to do our coronavirus example. Miss Reed was tagged in a video to do the ice bucket challenge. In one day, she had to do the challenge, then tag 3 people who would do the same. How many days would it take for 2,187 people to do the challenge? How many people will do the challenge in 4 days? So we're going to be using our formula here for exponential growth, which is y equals ab to the x power. Our a stands for our initial value. Our b is the rate at which it's changing, so what we are multiplying by each time. Our x in this situation is going to be the number of days that has passed. And we know this because this whole problem, it changes every 1 day. So the number of days is changing. And our y is how many new people are doing this challenge every day. And I know this because if I were to write an equation, this y, or how many people are doing it, is a function of x. However many number of days impacts however many people are going to make this ice bucket challenge video. So Miss Reed was tagged in a video. One person was tagged in a video. So our initial value here is 1. She had to do the video and then tag 3 people. So 3 is the number that is going to be increasing exponentially. Our going to stand for the number of days. And just y equals. Y equals 1 times 3 to the x power. So now what I'm going to do is I'm going to solve my first problem. How many days would it take for 2,187 people to do the challenge? So I'm going to plug that in. People doing the challenge is my y value. So 2,187 equals 3 to the x power. So now what I need to figure out is how many times we multiply 3 by itself to get 2,187. I got 7, right? It takes 7 times, 3 times 3 times 3 times 3 times 3 times 3 times 3 will give me 2,187. So 2,187 is equivalent to 3 to the 7th power, which is equivalent to 3 times 3. So our x is 7 days. It would take 7 days for 2,187 people to do the ice bucket challenge. This next question says, how many people will do the challenge in 4 days? This next question says, how many people will do the challenge in 4 days? So what I'm going to do is substitute in a 4 for x. Y equals 1 times 3 to the 4th power. I'm going to do this 3 to the 4th power first, and then I'll worry about this one. So 3 to the 4th power is 81. 1 times 81 is just 81, so y equals 81 people will do the ice bucket challenge in 4 days. Before we move on to this problem about coronavirus, I want to pause and give you an opportunity to consider if you are mentally and emotionally prepared to be talking about coronavirus right now. I totally understand that many of you might have family members in the medical professions, or you might just be generally feeling anxious about it. And if that is the case, I want you to know that you are allowed to stop this video right now and move on to your quizzes assignment. I prioritize you and your mental health and everything that you feel more than I care about if you can do this one particular assignment. However, if you do want to learn more about coronavirus, you are interested, we can get started right now. This problem, it is a real-world application of what we're learning about in school. I do want to point out, though, that these numbers are projections and may not necessarily represent the actual number of cases of COVID-19. Also, because of testing, and there have been areas where there are a lack of tests and a lack of resources, and some people who probably haven't been able to get tested. The numbers that you are seeing online also may not be totally accurate because not everybody is being tested. I also want to say that the equation that we're using for this COVID-19 example is a simplified version of this equation. It's actually kind of a lot more complicated than this, and there are expert mathematicians who are working on an equation. So the equation that we are using is an Algebra 8th grade friendly model. I do just want to throw that out there. The Washington Post says it takes 2.5 days for the coronavirus infected population to double. How many new people are infected after 7 days, 14 days, 21 days? So from this problem, we're going to be looking for an initial value, a rate, a number of new infections, and what we're going to put in the exponent. So our initial value, we are going to assume that we started with one person with this virus. Our rate is what is happening to the numbers. So in this case, the population is doubling. So our rate is 2. Our y value is the number of new infections. So that's what we're going to be solving for in in this problem. But our exponent is where things get tricky because it's not just x. See, the Washington Post says it takes 2.5 days for the infected population to double. So what we are actually going to put in this exponent is d for days divided by 2.5. And the reason we're going to write it like this, d divided by 2.5, is because the d represents how many, I guess, rounds of infection are happening. And we know that a round of infection is about 2.5 days. So, going on to plugging in our values, we're going to keep our y equals, our initial value is 1. Our b value is our rate, the population is doubling, so we'll put 2. And it's to the power of d over 2.5. Y equals 1 times 2 to the power of d over 2.5, where this d represents the number of days, and this y represents the number of new infections. Like I said, this is a simplified version. There are a lot of other factors that are going into it. I've actually attached down below a couple of different articles that explain the different factors in slightly different ways. So, now we're going to solve the problem. How many new people are infected after 7 days? So I'll plug in a 7 for D. Y equals 1 times 2 to the 7 over 2.5 power. Now, because of order of operations, I'm going to solve and find what this exponent actually is first. So this ends up being 1 times 2 to the 2.8 power. Now on your calculator, do you remember the x to the y button or the y to the x button? You are going to write into your calculator 2 to the 2.8 power, and that gives you about 7 people. So after 7 days, we have about 7 new infections. Now I want to know how many new people are infected after 14 days. So y equals 1 times 2 to the 14 divided by 2.5, which is 1 times 2 to the 5.6 power, which is about 49 people. So after 14 days, 49 people would have the virus. What about 21 days? Y equals 1 times 2 to the 21 over 2.5 power, which is 1 times 2 to the 11.2 power, which is 2,353 people. Thank you for watching. Don't forget to comment to me what your workspace is right now, and you can move on to your quizz's assignment.